In the previous video, we have discussed what is first normal form and how to identify that a given table is in first normal form or not, right? Basically, we have discussed all the 4 rules for a relation to be in first normal form, all the 4 important rules, right? And I have already told you that if they will give you a relational schema something like this, relation is given having these attributes and functional dependencies are given, right? Then obviously that schema would be in first normal form. They will never give you, or hardly they will give you a table and they will ask that tell me this table is in first normal form or not, right? Because first normal form is the basic point, the basic step of normalization. So always they will give you a table or the schema in first normal form. Now the important point is you have to identify that as in second normal form, third normal form, BCNF, something like this. And if not, then convert it into the desired normal form, right? So in GATE and NET, these type of questions will be asked. They will give you these type of questions, functional dependencies are given, and they will ask you that which highest normal form is there in this relation. So you have to find it out. So we have only functional dependencies, right? So this functional dependencies will play very important role here. So I have already discussed what is functional dependencies, trivial functional dependency, non-trivial functional dependencies, and Armstrong axioms, or you can say inference rules of functional dependencies. So first you check out those videos. And second important point is here what you should know how to calculate candidate keys in a relation. Candidate keys plays very important role. Without finding out the candidate keys, you cannot solve the problem of normalization. Second normal form, third normal form, BCNF, fourth, fifth, like this, right? So candidate keys, you should know that also. We have discussed how to find out candidate keys in a given relation, all the candidate keys, not one, all candidate keys, right? With a simple trick. So you can check out that video in the side button, right? And after that come to this video. So now in this video we will discuss how to find out that a particular given relation is in second normal form or not, right? What are the rules for a relation to be in second normal form? There are basically 2 rules. First rule is very simple, that relation should be in first normal form, and I have already told you if they will give you this type of question that a relational schema is given, that is by default that will be in first normal form, right? So first rule is a relation is said to be in second normal form if, first rule is if it is in first normal form, right? And this already we by default we consider that this is in first normal form, right? Second rule is what? There would be no partial dependency present in the relation. Now what is partial dependency, that also I'll discuss. So this, what is this partial dependency now? I hope everybody knows what is functional dependency, right? I have already discussed. You can check out that video in the side button. Now what is partial functional dependency? Or you can write down it something like this: proper subset of candidate key of any candidate key. If suppose there are 3 candidate keys, so proper subset of any candidate key will determine known prime attribute. If this kind of dependency is there in the list of functional dependency given, then that is known as partial dependency, right? Proper subset of candidate key. See, suppose candidate key here is ADE. So proper subset of this is what? AD is also proper subset, DE is also proper subset, or you can write AE, ADE. 6 proper subset are there, right? So if any proper subset of the candidate key will determine the known prime attribute, then that is partial dependency, and that should not present in the relation. If partial dependency is there in the relation, then that relation is not in second normal form. Now what is this known prime attribute? I hope you got what is partial dependency, right? Partial functional dependency, you can say. Now obviously I'll discuss this with the help of this example, then you will get it better. Now what is known prime attribute? See, I have already discussed prime attribute, known prime attribute. Prime attributes are those which are part of candidate keys, right? Suppose here in this relation, suppose I am not saying that these are the candidate keys, suppose AD is candidate key, BC is candidate key, two candidate keys are there in this relation, right? So prime attributes would be what? A, B, C, D, E. The attributes which are part of candidate keys or which are making the candidate key, those are prime attributes. And the remaining attributes are, means the attributes which are not part of candidate key, which are, those are non-prime attributes. So here non-prime attribute would be, I guess, only F would be non-prime attribute, right? So I hope you got now what is non-prime attribute. So now let us discuss it with this example. Let us find out this relation is in second normal form or not, right? And after that we will discuss it with the help of 2 or 3 examples, with all the type of examples. I will take all the type of examples, and after that we will see if this is not in second normal form, then how to convert it into second normal form, right? So now this is in first normal form, right? By default the relational schema is given and this condition is satisfied. Now you have to find out this condition, means there should be no partial dependency. So now you have to find out this type of functional dependency here. If this type of functional dependency present here, then you can say this is not in second normal form, right? But for this you have to find out what is candidate key. To find out the proper subset of candidate keys, you have to find out all the candidate keys from a relation, right? Without finding candidate keys you cannot do anything. So that is very important. Now how to find out candidate keys? We have already discussed. Candidate key is what? The minimal super key. So now here how to find out? By taking the attribute closure. So that also I have discussed what is attribute closure and how to find out the attribute closure of an attribute, right? So I'll take first of all the attributes, find out the closure. Definitely it will find out all the attributes. So this is what definitely a super key, right? Because of reflexivity property. Now try to discard attributes from here. So now A can determine B. So we have A, so I can discard B from here, because if you have A, then A can determine itself and A can determine B also. So you can discard B. A can determine B, B can determine C. So by transitivity property A can determine C, so you can discard C. C can determine D, so by transitivity property A can also determine D, so you can discard D. Now A can determine D and D can determine E, so by default A can determine E, means by transitivity property, so you can discard E. Can you discard F? No, we don't have such type of dependency that using that we can discard F, because nothing is going to find out, nothing is determining here F. So now A and F, you can take the closure and you will find all the attributes. So this would be the super key, right? So how to find out that that is candidate key or not? Proper subset is A and F. Proper subset is, if proper subset is also super key, then that would not be a candidate key. You can find out closure of A. Closure of A will find out A, right, itself, then B, then C, then D, then E, not F. So this is not super key. F closure would be what? Only F. F can determine itself. This is trivial functional dependency, nothing else. So this is also not super key. So here you can say AF is candidate key, because no proper subset of super key, this super key is super key, right? So here AF is what? Candidate key. We have got one candidate key, that is AF. So now we have got as well as the prime attributes, right? Means A and F. A comma F are prime attributes. Now you have to find out, still there are another more candidate keys exist in the relation or not, because we have got only one candidate key. Now how to find out that thing? If the prime attributes are present on the right hand side of any functional dependency, then definitely there would be more candidate keys present. If not, then there would be no more candidate key. So find out, is A present on the right hand side of any functional dependency? No. F? No. So in this relation only one candidate key is there, that is AF. No more candidate key you will find, right? That is the short trick. Fine. Now if AF is candidate key, then here non-prime attributes are AF are prime attributes. So remaining means B, C, D, E. These are non-prime attributes. Now we have non-prime attributes also and candidate key also. Now you can check out this type of dependency exists here or not. See, proper subset of candidate key. Proper subset of this candidate key is what? Because I have only one candidate key, A and F, right? Is A or F determining any non-prime attribute? See, here F is not determining anything, so it cannot be there. It cannot be a case. Now, is A determining? Here see, A is determining B, right? And B is what? Non-prime attribute. Means you got this type of functional dependency here, right? So this is what A determine B. This is what partial dependency. So here partial dependency exists. So this relation is not in second normal form. Or in another word you can say, see, complete AF is candidate key and definitely it is also primary key, right? And only a part of this primary key, only a part of this primary key or candidate key is determining a non-prime attribute. Only a part, not the complete candidate key. So that could not be possible, right? So now let us discuss it with one more example. So let us take this example now. This is the relation having 4 attributes and these are the functional dependencies given here. So this relation is definitely by default in first normal form, right? Now you have to check the partial dependency present here or not. How to find out partial dependency? See, this thing you have to take care. If you know how to find out partial dependency, what is partial dependency, then you can easily find out that a particular relation is in second normal form or not. This is the important concept here, right? So partial dependency means you have to find out this kind of dependency in the given list. For this kind of dependency, you have to find out candidate keys, all the candidate keys, and definitely then you can find out the non-prime attributes, right? So now, first of all, find out the candidate keys. How to find out? Take all the attributes, take the closure, and all the attributes definitely would be super key, right? Now, try to discard as many attributes as you can because candidate key is minimal super key. Now, see, check the dependencies. A, B, both can determine C, D. Do you have A, B? Yes, I have A, B, so I can determine both C and D. So, A, B closure would also find out A, B itself because of reflexivity, and A, B can determine C, D. Do you have A, B? Yes, so I can determine C, D. So, this closure of this A, B is containing all the attributes. So, A, B is what? Super key. A, B is still a super key, right? Now, can you discard any more attribute from A, B? C can determine A. Do you have C? No. D can determine B, but we don't have D. So we cannot discard any more attribute, right? So now check out, is A, B is candidate key or not? Find out the proper subset, that is A and B. Find out closure of A. Find out A and B individual can be a super key or not. Closure of A. Single A can determine A, but we don't have A, B, so we cannot determine C, D. So only A can determine only itself. B can determine B, only B. So this is not super key, this is not super key. So it means candidate key. A, B is what? Candidate key. We have got one candidate key. It means prime attributes are A and B. Right now check more candidate keys are present or not. How to check? If prime attributes are present on the right hand side of any functional dependency, then definitely more candidate keys would be there. See, A is present on the right hand side of this functional dependency, right? Means you will get more candidate keys here, right? Now, how to do that thing? See, existing candidate key is this one. So, at the place of A, you can replace A with C. After replacing, you will get C, B, right? And second option is, see, B is also prime attribute and B is present on the right hand side of D. So, second option is, at the place of B, you can write down D. But I am not saying that this and this would be definitely candidate keys. Still you need to find out. But yeah, I can say that this and this are super keys, right? So now check out the proper subset of B and C. One is B, one is C. Check out these are super keys or not. Find out B closure, C. B is not a super key, C closure. C can determine itself, C can determine A, nothing else. So this is not super key. So it means BC is also candidate key, right? So now we go to one more prime attribute, that is C. Now check out AD is candidate key or not. A closure, not candidate key. D closure can find out D and B, nothing else. So this is also not super key. So this is also candidate key here. Fine. So A and D. So D is also prime attribute. Right. Now you can check. We have got 2 more prime attributes. Now check, these are available on the right hand side of any functional dependencies or not. Yes, available. See, this you can write down something like this. By splitting property, AB can determine C and AB can determine D. So at the place of C, you can replace it with AB. Here AB. So obviously we will not write ABB AB, but we have got on the candidate key AB, so no need to replace. And at D also AB, at D also AB. So we have already got AB, so no need to replace. So now these are the candidate key, 3 candidate keys in this relation, and prime attributes are A, B, C, D. Now here all the attributes of the relations are prime attributes. So definitely that relation would be in second normal form. Why so? Because there is no known prime attribute. If no known prime attribute, then you will never get this type of situation, because proper subset of candidate key is determining known prime attribute. This is partial dependency, but we don't have any known prime attribute. So you will never get this kind of dependency here, right? See, at the right hand side known prime attribute should be there. You can check. Right hand side CD, but CD is prime attribute, A is also prime attribute, B is also prime attribute. Fine. So if all the attribute of a relation are prime attributes, then that relation is definitely in second normal form. Fine. Let us take third example. So third is this type of question. 4 attributes are there in a relation. These are the functional dependency. Find out the candidate key first of all. How to find out? Simple rule. Take all the attributes. Obviously the closure would be A, B, C, D. Find out all the attributes. So this would be super key, right? Now try to discard attributes. How to discard? Check the functional dependency. A is determining B. So do you have A? Yes, I can discard B. A is determining B, B is determining C. So by transitivity property, A will determine C. So I can discard C because I have A. Now third is what? C is determining D. Means A can determine C and C can determine D by transitivity property. So means here you have A, so you can discard D. So now we are left with only A. So find out A closure. Is it super key or not? A will determine itself. So we have A will determine B. Do you have A? Yes. So it will determine B, B will determine C, C will determine D. So I am getting all the attributes of a relation. So A is what? Super key, right? Now, is A candidate key or not? Definitely yes. Why so? Because proper subset of this A is what? Phi only, right? How to find out proper subset, that also I have discussed in the previous video. You can check out that video in the side button, right? That is phi, and phi set of attribute cannot determine any attribute of a relation. So definitely if one attribute is there in a super key, then definitely that would be candidate key. So here A is what? Candidate key. So prime attribute we got A. Now check, prime attribute is available on the right hand side of any functional dependency. Here we have B, here we have C, here we have D. No. It means there would not be no more candidate keys. Here we have only one candidate key, that is A. Now see, here candidate key is having only one attribute. So proper subset of candidate key, can you get any proper subset of this? Proper subset would be what? Phi only. No attribute would be there, right? Now there is no proper subset of candidate key. So definitely we will never get this kind of dependency here. So there is no partial dependency. So this would be in second normal form. This relation would be in second normal form. So you can say something like this: if candidate key is having only single attribute, right, then definitely that relation would be in second normal form, right? It's not like that. Maybe in some case, in some relation, one candidate key is having single attribute, another candidate key is having 2 attribute. In that case, you cannot say that there would not be any partial dependency, because one candidate key is having 2 attributes. So you can find out proper subset of this. You cannot find out proper subset of this, but you can find out proper subset of this, right? So it means if all the candidate keys here, luckily I have only one candidate key, but if suppose all the candidate keys, 2 candidate keys are there or 3 candidate keys are there, and all the 3 candidate keys are having single attribute, then definitely there would be no partial dependency, and definitely that relation would be in second normal form. Now I hope you got how to find out that particular relation is in second normal form or not, right? And what is partial dependency. Now see, one question for you is, here this is the relation given, and functional dependencies are two functional dependencies only, A to B, B to D. I think this is very simple question. So you can tell me in the comment box that this relation is in second normal form or not, right? Now the question is, if not in second normal form, then how to convert it into second normal form, right? So we will decompose that relation. See, this is not in second normal form, so you will decompose this, you will divide it. Now how to decompose it, that I guess it's not the right time to tell, because first of all I will tell you what is decomposition, what are types of decomposition. We have lossy decomposition, we have lossless decomposition, right? So definitely there should be lossless decomposition, not this lossy decomposition. Now I am going to tell you in the next video that what is lossy decomposition and what is lossless decomposition, right? And how to decompose a particular relation into lossless decomposition, right? After that only I can I guess you can easily get that how to convert it into second normal form, how to decompose the relation, right? It's not the right time to tell you, right? Now in the next video I am going to tell you that what is third normal form and how to find out that a particular relation, particular given relation is in third normal form or not, the basic idea, right? So I guess now it's done with the second normal form. So now I'll see you in the next video. Till then, bye bye, take care.